Hello guys, I hope you are all doing well. In this video we are going to talk about pointers arithmetic. We will talk about various operations that we can perform on pointers or addresses. So let's begin. So far we have talked about the relationship between addresses and pointers. For example, a single pointer is able to hold the main address of normal variable. Similarly, a double pointer is able to hold the main address of single pointer. Right? So instead of saying that we are going to study about pointers arithmetic, we will be actually looking operation that we can perform on addresses. Okay, this is much better approach than directly jumping in the pointers arithmetic. Okay, now remember that we will be talking about addresses, and from there you will yourself will understand okay what are allowed operations, what are not. Okay, now first point is that okay, only two operations can be performed on addresses, can be performed on addresses, right? And these operations are addition and subtraction. Okay, now there are two things, addition and subtraction. Okay, now it means that if there is an address, let's say there is a variable int a and its main address would be and a. Okay, now if I need to perform addition, then I have to perform it with some value. Okay, remember that here it should be some value, right? Value, I mean by value is that I can, let's say here is b equals to 1 also. Okay, now here I can do and a plus b, right? Since b is holding a value is 1. Okay, similarly I can perform and a plus 6. Okay, and a plus a character, let's say a. Okay, so these are things are allowed when we talked about addition. Okay, now the main thing is this one, that during addition, when we do addition, only a value can be present here. Okay, only a value can be added to a address. Okay, but in subtraction we see that a value can occur. Okay, and also any other address could also come. Okay, add value or any other address. Okay, address means if I am talking about single variable, then the address should be of single variable, or let's say normal variable, then the address should be of normal variable. Okay, now here both this is possible, but here only value can come. Here value or address of the same type can come. From the same type I mean that here I can write and a minus and b, right? But let's say if there is a pointer int asterisk p, let's say, and its main address would be and p. Okay, so now I cannot do something like this, right? Okay, so now let's talk about another point. Now let's try to understand point number 2. Okay, let's say there is a variable int a and b, and also there is a pointer variable asterisk p. Okay, now if I do and of a plus 1, right? Now whatever will be its output, it will be treated as address of normal variable. Okay, because and a is normal variable, a is normal variable, so whatever I am writing here or whatever operation I am performing here, it will be treated as address of normal variable. Let's do plus minus. Okay, plus minus with value. Okay, similarly if I talk about the single pointer, then if I do end of p plus minus any constant or value, let's say 5. Okay, whatever will be the output will be address of main address or address of single pointer. Okay, will be treated as address of single pointer, right? Why? Because this is a single pointer, right? Similarly, if there is double asterisk q, then end of q plus minus with any value, let's say b equals to 2, okay, and here if I do b, then whatever will be the output will be considered as address of double pointer. Why? Because this is the main address of double pointer. Okay, remember this point, because when we will be doing some numericals, then we will see, okay, these things are really helpful. Okay, so this was about the second point. One more thing is that here and a plus minus I am writing a value, okay, but when it comes to address minus address, let's say, then there will be some rules that we will talk about in the later. Okay, in the last we will talk about what happens when an address is subtracted by another address. Okay, now our third point will tell after performing the operation what will be the output. Okay, let's say there was an integer variable a, right, and its address is, let's say it is 1, okay, its value is 1, this is a, and end of a, let's say, is 14212, right? Let's assume. Okay, now if I perform an operation, let's say and a plus 1, now what will be the output? Okay, this depends on the size of this variable. Okay, what is the size of this variable? It can be either of 2 byte or 4 byte, right? For 64-bit compilers, it is generally of 4 byte, and for 16-bit it is generally of 2 byte. Okay, so it depends whether it is of 2 byte or 4 byte. For 32-bit also it is generally 4 byte. Okay, I am considering here, let's say it is of only 2 byte. Just for here I am assuming that it is of 2 byte integer. Now what will be the output? Okay, now what I am doing, and a plus 1. Okay, so and a plus 1 means the output, final output, if I do here printf, let's say I do here printf, right, %u, right, now my output will be 14214. Why 214 is that? Because I am increasing it with 1. Okay, and 1 means here will be increment by 2. Okay, for a general expression we can write, if this is given, okay, x, okay, so our output will be end of a plus size into this size, okay, size of variable. Okay, and this is for plus minus, and this is also for when I am talking about value. Okay, now when an address is added or subtracted with any value, right, then output will be address plus what is the value, then size of that variable. For example, here if I write here end of a minus 2, right, so our output will be 14212. Okay, this will be given generally. Okay, if you are doing some numerical, this will be given. Okay, and even if it is not given, then the question pattern will be something different. Then I am writing here minus, since minus is asked. Then what is x? X is 2, size of variable is 2. Okay, so our output will be 14212 minus 4, so it will be 14208. Okay, so that will be our output, or we can say this is the address we found. Okay, and according to second point, whatever is the output of this will be treated now as a address of normal variable. Okay, this was according to the second point. Why it is important? Let's say there was a pointer variable, right? Now if there is a pointer variable, p can hold the address of normal variable. This is correct. So if I ask you if p can hold the address of this, let's say, can it hold the address of this? Yes, it is. Why? Because after performing this operation and a plus 6, whatever I will get will also be the address of a normal variable, and we know from the previous videos that p is able to hold the address of normal variable. Okay, this is why we talked about second point. Okay, similarly if I say and a minus 8, okay, and I am storing it in single pointer, is it valid? Yes, it is valid. okay, because whatever is coming, it is the main address of normal variable, and then it is going to assign, okay, and p can hold the address of normal variable, okay. So these 3 points talks a lot about the pointers arithmetic, okay. Now let's take some examples here. Now here is an example written in which a is assigned to 5, so a is 5 and its address is also given 14122, right. Then b is also given, let's say b, its value is 6 and address is given as 14124, right. Then it is written p equals to and a plus 1, p equals to and a plus 1, okay. Now is this a valid statement? Let's see. This is a single pointer variable, right? So single pointer variable can hold the address of normal variable. We had talked about it, okay. So this was the main address of normal variable plus 1, okay. Whatever is the output of this will also be considered as the address of a normal variable, okay. So this is a valid statement. First of all, this is a valid statement, okay. Now it is also given that size of the integer of 2 byte, it is of 2 byte, right. Then it is asking me printf asterisk p, okay. Now I have to find whatever is the address after performing this operation, what is the address and what is the value present inside it, okay. So here if we see end of a is 14122, right, and now I am performing with plus 1, okay. So our output will be 14122 plus 1 into 2. Why into 2? Multiply by 2 because it is of 2 byte. So our final output is become 14124, okay. Now p has 14124, okay. Remember, in virtually remember that it is now having the address of, if I simply print here, let's say if I write now printf %u and I do p, okay. After that statement, let's say if I do here printf %u p, so the address it will give me, or the output it will give me, will be 14124, right. Now I have to do dereference it, okay, asterisk p. Now what is the value present in this address, okay. It is given that address of b is 14124, okay, 14124 and 14124, okay. Now what is the value present in this address? What is the value present in this address, okay. So what is the value? It is present 6, okay. So if I do asterisk p, so output will be 6. So here our final output will be 6, right. Now let's see another example. Now here it is given that a equals to 5, okay. So let's say a 5 and a is some value, right. It is not given. Then a single pointer is also given, okay. Then here it is p and it also have some address, okay. We don't know what is the address, okay. Now let's say it is written here p equals to end of a, right. So right now it is holding the address of a, okay. Now if I say here I do perform an operation, let's say p plus plus, and the question is that this is valid or not, okay, p plus plus. Now what is the equivalent meaning of this operator is that p equals to p plus 1 in general way, right. This is the meaning, p equals to p plus 1, okay. Right now p is holding the main address of normal variable, so it is holding the address of normal variable, right. So if you see here, is it a valid statement? Yes, it is a valid statement because we had seen it before that after addition with a value of a normal variable, it will give me as any address of a normal variable, right. And since it is a single pointer, it can hold the address, okay. So this is the valid statement, right. Now let's see another thing. If I do here end of p plus plus, right. Similarly, if let's stick to it first. Similarly, p minus minus is also valid, minus minus p is also valid, and plus plus p is also valid, okay. Same reason here, okay. Now if we see here end of p plus plus, okay. Now is this a valid statement? Okay, let's see. It means that end of p equals to end of p plus 1, okay. In the first video of this series, I had told you that main address can never change, what I'm trying to do here is that I'm trying to change this address, right? So I'm trying to change the main address. So main address can never change. So this will give us error, and this statement is not valid. Okay. Similarly, if I say here AND of A plus plus, okay, AND of A is what? Address, main address, right? This is main address, and if it means that I am trying to change it with 1, okay, with addition of 1. So is this a valid statement? No. Why? Because I am trying to change the main address of a variable, and main address of any variable, whether it is a single variable or a pointer variable, it can never change. Okay, so this is also not valid. Okay, now let's see some other examples. Now there is one more important point, that what happens when an address is subtracted from another address. Okay, here I had written two variables A and B, which is of 2 bytes, and address of A is given and address of B is given. Okay, now the formula to solve is that, let's say there is address A minus address B. Okay, first of all we will find its difference, then we will divide with the size of variable. Okay, for example, here address of A was 14124 minus 14120, and size of the variable I am considering here is of 2 byte, right? So our output will be 4 by 2 and final output will be 2. Okay, so if we printf %u with this, our output will be 2. Instead of integer, if there is, let's say, character is written, okay, and character is of 1 byte, right? Now what will happen? Same formula, instead of here it will be now written 1, okay, and our final output will become 4, right? So this is what happens when I subtract one address with another address. Now another thing is that size of the pointer variable is 2 byte for 16-bit machines. Okay, for 32-bit machines it is of 4 byte, and for 64-bit machines it is of 8 byte, right? When you are solving any question, it will be generally given to you. Okay, another thing, that it is independent of the data type. For example, considering 64-bit of machines, okay, if I am writing int star A, let's say, and character star C, okay, now both of these pointer variable will be of 8 byte, right? Will be of 8 byte. Okay, so the size of pointer variable is independent of the data type. Okay, one last thing to remember, that when I perform an operation plus minus with a value, okay, which we see in our second point, this value can either be an integer or character, right? It cannot be float. Float is not allowed with the operation with the addresses. Okay, for example, this is valid, this is also valid, but this is 16.2, which is a float value, this is not valid. Okay, so remember these 2 points also. Okay, so that's all for today, guys. I hope you like the video. If you have any doubt, you can comment it down. Thanks for watching, and I hope to see you in the next video.